My team ID is MY054 and I'm working with data of computer vision that can see in the dark. Night shift workers at dangerous workplaces such as oil and gas stations not only exposed to fire and explosion hazard, but also exposed to night hazard such as fallings and isolations between workers, so causing fail access to assistance immediately if they need. So the safety monitoring is needed by recognizing the dangerous human actions. Therefore, in our projects, we aim to develop an algorithm for human action recognition in the dark environment by utilizing knowledge in computer vision, with the objective of, firstly, to investigate a suitable method for dark video frame enhancement, secondly, to implement a computer vision method to facilitate human action recognition in the dark, and thirdly, to evaluate the recognition accuracy and the speed of the proposed method. One of the current solutions for the problem is the wearable sensor. However, wearable sensor can be ignition source if powered by electricity, and also it requires additional effort to handle issues with machines' strong electromagnetic field that could interfere with the sensor operations. And another current solution for the problems is the additional hardware integrated with software algorithm to operate in the dark. For example, CCTV. The limitations of this approach is that it still relies on offline videos to collect related information, making it unable to provide real-time alerts while monitoring the incident scenes. So it requires additional hardware to operate in dark for the scenes to be visible. So our solutions focus on algorithms that are able to provide enhancement for dark scene to become more visually receptive, and then recognize the person actions in the scene at high speed. So the proposed models are capable of monitoring the worker safety in the dark without additional hardware except a video camera. And our model is lightweight, which provides flexibility in terms of a hardware resource. So now let's have a demo on the dataset that collected from the published resource. So the users who can benefit from our solutions are night shift workers who require safety monitoring. So there are a significant number of night shift workers worldwide that can benefit from our solutions. So the exact number may vary, but these workers are present in various locations where their jobs take place, so making the potential user base substantial. So immediate support can be provided if there is any incident occur, which reduce the fatality caused by incident due to poor visibility during night time. So this simple and cost-effective solutions brings about a positive change by promoting a safer and more efficient work environment for these workers. This is how the entire architecture of the proposed method looks like. So this is a two-stage model that combine the dark frame enhancement models and the action recognition models together. So how the algorithms basically work will be discussed later. So an important thing that need to be known is that the proposed models will train on two datasets in supervised manner. Right, so talking about the dataset, firstly is the MY054 dataset, which is a set of good lighting images that retouched by 5 experts. So this dataset will be augmented to get a corresponding dark versions of it, and this pair of images were then used for training the dark frame enhancement models. Secondly, the ARID dataset, which is a benchmark dataset containing dark videos that record 11 classes of human actions, including drink, jump, pick, pull, push, run, sit, stand, turn, walk, and wave. So it was mainly introduced for human action recognition tasks in the dark. So this dataset will be enhanced by the enhancement models and act as the training data for the action recognition network. So there is no any ground truth was provided in this dataset. Okay. For development, 4 tools has been used. So data preprocessing steps such as data annotations and the data augmentations were carried out with the help of the MATLAB supported powerful video labeler app that allows the annotations process to be automated, and image processing package for generating dark versions of the MIT5K dataset by applying various of noises such as salt and pepper, Gaussian noise, pixelations, and others. Visual Studio Code was used as a code editor for Python language, and then PyTorch is the requirement needed for executing the YOLO V7 models, while the TensorFlow will be utilized in developing the dark frame enhancement models. So now let's further focus on the architecture of the enhancement models. So this enhancement model composed of CNN layers that stack together with skip connections and concatenations so that the layers can learn the good lighting features at both low level and high level at the same time. So in this case, I first reduced the frame size to lower resolutions of 256 x 256, which helped to speed up the training process. So, but the models was actually designed to not be specific for a particular frame size, so that it is more flexible to the input requirements. So to be more specific, let's consider figure 5. So how the models work is that the models actually extract the good lighting features and map it onto the dark versions to achieve enhancement. Okay, so gamma is a differentiable parameter, hence I first introduced the gamma into the mean square area loss functions, and hence the initial gamma was given to be 1, meaning that there is no gamma corrections being applied to the image initially. So I then made use of the gradient optimization concept to update the gamma value for every training iterations. So the gamma was treated as a trainable parameter. Okay, so during backpropagations, the gradient of the loss functions with respect to the network parameter, including the gamma, will be computed, and this gradient will update the network parameter and at the same time will be utilized to update the gamma as well. So the positive or negative gradients will determine the gamma trend to be increased or decreased in order to minimize the loss. So increasing gamma make the frames brighter and closer to the target, and vice versa. So the optimal gamma value will finally be determined when the loss changes become steady. Alright, so on the right hand side showing the gamma corrections equations. Okay, and then the gamma value will be updated as gamma nu equal to gamma O plus gradients, and then at the last equations showing that the gamma value is introduced into the mean square area loss functions. Once the enhancement model has been trained, in order to enhance the dark video frame selected from ARID dataset, so all the frames will be passed through the models, and again the good lighting features will be mapped onto the dark frames, and the gamma corrections will be applied, but this times with the optimal gamma value. Okay, so for action recognition paths, I utilized the pre-trained YOLO-V7 and applied a transfer learning on enhanced versions of the ARID dataset that were annotated with action class labels and the bounding box coordinate so that it can be used as an action recognizer in my case. Okay, so the YOLO-V7 was originally designed for object detections. I aim to preserve the high-speed predictions features of the YOLO-V7 network for the action recognition task, and hence what I have done was that I eliminate the analysis of temporal information between the video frames and only focus on the spatial information for such purpose. So even though the eliminations of temporal information may reduce the recognition's performance, but it can greatly improve the speed to achieve real-time recognitions. So investigations and research is still needed to evaluate the recognition performance. So next part will be focusing on the proposed method performance analysis. Alright, so figure S shows the dark frame enhancement model's training loss at the left hand side, while the gamma trend at the right hand side. So the gamma shows an increasing trend, meaning that the dark version images were enhanced to be brighter and have better contrast. So as the gamma increase, the training loss decrease, which indicates that the dark images are getting closer to the good lighting images. So these are some examples of the enhanced ARD video frames. From upper to the lower rows are original frames and also the enhanced frames. Okay, so next, the performance of YOLO-V7 as action recognizer can be illustrated in figure 10. The recognizing performance is highly depends on how well the frame enhancement model can perform. So based on figure 10, three losses, mainly the bounding box loss, objectness loss, and the classification loss, are in decreasing trend. The precisions in terms of the mean average precisions at 0.5 threshold of the intersections of unions are increasing toward 80%. Okay, so the confusion matrices for the 11 classes of actions are also shown in figure 11 to visualize how well each classes is correctly predicted. The diagonal axis will indicate about these informations. So when plotting out the mean average positions for each action class, the visualizations are shown in figure 12. Okay, so the mean average positions of all classes of actions successfully achieve a number of active points 45%. So these are 4 examples of the predicted actions. Okay, the top left is drinking actions, and then bottom left is the picking actions. The top right illustrates the predicted action as walking, and then the bottom right is the predicted actions of pushing. Okay. By comparing the proposed method with some of the benchmark approach, our method achieved the third higher mean average precisions with 80.45%. So even though dark light and bright resonant they work on higher mean average precisions than the proposed method, but they are generally more computationally intensive, as what had been discussed and mentioned by the researcher listed. So based on the result obtained, some advantages and the limitations of the proposed method were summarized in the tables. So in conclusions, the adaptive gamma corrections ensure that the optimal gamma values can always be selected, which allow the proposed method performs better than the previous approach on the ARID dataset. Fast recognition in the dark without additional hardware is possible with the proposed method. So in futures, my work may be extended to include more outdoor scenarios and also to integrate the daytime's action recognition tasks into the current existing nighttime recognition algorithms to make the recognition tasks more adaptive. And also the imbalanced data set issues will also be solved in the futures to improve the overall model's performance. So that's all from me. Thank you.